Bismillahirrahmanirrahim. Assalamu Alaikum. Dear student, welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus Punjab Book Foundation Physics SSC 2 Unit number 14 Current Electricity. Today we will discuss about SLO base according to FDISC requirement numerical problems question number 5 to 8 in part 2 remaining inshallah in next part. Now let's start the today lesson in numerical problem question number 5 given statement. Two resistance of 2 kilo ohm and 8 kilo ohm are joined in series. If a 10-volt battery is connecting across the end of this combination, find the following quantities. Here in first part, the equivalent resistance of the series combination, and in B part, current passing through each resistor, and also in C part, the potential difference across each resistance. Now we will write the given data according to given statement. The value of first resistance R1 is equal to 2 kilo ohm. 1 kilo is equal to 10 raised to power 3. So R1 is equal to 2 multiplied by 10 raised to power 3 ohm. And similarly, the value of second resistance R2 is equal to 8 kilo ohm. Here kilo is 10 raised to power 3. So R2 is equal to 8 multiplied by 10 raised to power 3 ohm. Similarly, the voltage V is equal to 10 volt. So we have required that equivalent resistance R equivalent is equal to question mark in B part current of each resistance. So current is equal to I, and in C part potential difference across each resistor. So V1 and V2 is also fine. Now let's start the solution. In solution of numerical problem question number 5, we can use the formula. First of all, for A part, equivalent resistance R equivalent is equal to R1 plus R2, and for B part, we using the Ohm's law, V is equal to IR. Here R equivalent is also used because potential difference according to the Ohm's law, V is equal to IR equivalent. And in C part, we can use the formula is also V is equal to IR, but R1 and R2 for the both values. Now to find the solution in A part, R equivalent is equal to R1 plus R2, that is equal to 2 kilo ohm plus 8 kilo ohm, that is equal to 10 kilo ohm. So the equivalent resistance is equal to 10 kilo ohm. Now in B part, circuit in series, so current is always same. So I is equal to I1, that is equal to I2. Now according to the Ohm's law, V is equal to I R equivalent. So I is equal to V upon R equivalent. Here putting the value of V and R equivalent, then current I is equal to 1 multiplied by 10 raised to power minus 3 ampere. Now I is equal to 1 milliampere. Let's start the C part in V1 and V2. For V1, we using the Ohm's law, V is equal to IR. Then V1 is equal to IR1. I is equal to 1 multiplied by 10 raised to power minus 3, and R1 is equal to 2 multiplied by 10 raised to power 3. Here 10 raised to power minus 3 and 10 raised to power 3 cancel to each other. 2 ones are 2, so V1 is equal to 2 volt. Similarly, we can find the voltage V2. Then V2 is equal to IR2. Putting the values, then I1 multiplied by 10 raised to power minus 3 multiplied by R2 is 8 multiplied by 10 raised to power 3. Here we can write the value of 8. So 8 ones are 8, then voltage V2 is equal to 8 volt. Then result R equivalent is equal to 10 kilo ohm, and in B part I is equal to 1 milliampere, and in C part V1 is equal to 2 volt and V2 is equal to 8 volt. Now let's start the next numerical. In next numerical problem, question number 6. Given statement, two resistance of 6 kilo ohm and 12 kilo ohm are connecting in a parallel. In previous question, the given relation in series, and in this question, the given relation in a parallel combination. So, a a battery of 6 volt is connecting across its end. Find the value of the following quantities. Here, similarly, same quantities, equivalent resistance of parallel combination, and in B part, current passing through the each resistance, and also the potential difference across the each resistance. Here, in a parallel combination, we can write first of all given data and required, then we write the formulas that are different from the previous numerical. Now, write the given data. In a R1 is equal to 6 kilo ohm. 1 kilo is equal to 10 raised to power 3. So R1 is equal to 6 multiplied by 10 raised to power 3 ohm. R2 is equal to 2 kilo ohm, that is equal to 2 multiplied by 10 raised to power 3 ohm. Here not R2, that is value is 12. So R2 is equal to 12 kilo ohm, and that is equal to 12 multiplied by 10 raised to power 3 ohm. And the voltage of battery V is equal to 6 volt. Now we can require that in our first part equivalent resistance are equivalent, and in B part current through each resistance I1 and also I2, and in C part the potential difference across the each resistor, that is denoted by V. Now we can write the formulas that use in the solution of question number 6. For first part, in a parallel combination, 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2. And in V part, we using the formula V is equal to IR according to the Ohm's law. And similarly, we can find the solution. So, in our first part, A part, 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2. Now, putting the values, then 1 upon R equivalent is equal to 1 upon 6 multiplied by 10 raised to power 3 plus 1 upon 12 multiplied by 10 raised to power 3. Here we can calculate the value R equivalent is equal to 4 multiplied by 10 raised to power 3 ohm. That is also equal to R equivalent is equal to 4 kilo ohm. So the value of equivalent resistance, that is equal to 4 kilo ohm. Now we will find the B part. In B part, quantity of current in the first resistance I1 is equal to V upon R1. That is equal to I1 is equal to 6 upon 6 multiplied by 10 raised to power 3. Then 6 cancel out by 6. So I1 is equal to 1 multiplied by 10 raised to power minus 3. This implies that current I1 is equal to 1 milliampere. Similarly, we can find the quantity of current in second resistance. So I2 is equal to V upon R2. That is equal to I2 is equal to 6 upon 12 multiplied by 10 raised to power 3. 6 ones are 6, 6 twos are 12. 1 upon 2, that is equal to 0.5. So 0.5 multiplied by 10 raised to power minus 3. This implies that I2 is equal to 0.5 milliampere. Similarly, we can find the potential difference. Circuit are parallel, so the voltage are remain same. Then V1 is equal to V2 is equal to V3, so V is equal to 6 volt. Here potential difference always remains same, so V is equal to 6 volt. Then result of the answer in A part R equivalent is equal to 4 kilo ohm. In B part I1 is equal to 1 milliampere, I2 is equal to 0.5 milliampere, and in C part voltage V is equal to 6 volt. Now let's start the next numerical problem. In numerical problem question number 7, given statement. An electric bulb is marked with 220 volt of 100 watt. Find the resistance of the filament of the bulb. If the bulb is used 5 hours in a daily, find the energy in kilowatt or consumed by the bulb in 1 month, and 1 month is equal to 30 days. Now write the given data. Voltage of bulb V is equal to 220 watt, and also power of bulb, that is equal to P is equal to 100 watt. Now we can write the daily use of the time, that is equal to T is equal to 5 hours, and number of days in a 1 month, that is equal to 30 days. Now we can calculate the resistance R is equal to question mark, and also the energy consumed by the bulb E is equal to question mark. Now we using the formula for the first part of the resistance, P is equal to V square upon R, and for the B part we can use the formula E is equal to P multiplied by T divided by 1000. Now we can calculate the value for a solution of numerical 7. We know that P is equal to V square over R. Here we can find the resistance, so R is equal to V square upon P. Putting the value of V and T, then R is equal to 48,400 divided by 100. Here zeros cancel to zeros, then resistance R is equal to 484 ohm. Now we can calculate the energy in or, then time multiplied by power divided by 1000. Now putting the values, then energy E is equal to 30 days multiplied by 5 or multiplied by power 100 watt divided by 1000. Then we can multiply by 5 multiplied by 3. So the answer of energy E is equal to 15 kilowatt per hour. Now the answer of the question, the result is R resistance is 484 ohm and energy E is equal to 15 kilowatt hour. Now we can move the numerical problem question number 8. In question number 8, an incident light bulb with an operating resistance of 95 ohm is label of 150 watt. If the bulb is designed for use in 120 watt circuit or 220 watt circuit. Now we can write the given data. Resistance R is equal to 95 ohm and power P is equal to 150 watt. Also given that the voltage, so we can find the difference 220 watt to 120, so remaining answer is 100. Here this value is watt, not a watt, so for which the bulb is designed. Now according to the Ohm's law, V is equal to IR and power P is equal to I square R. Now we can calculate the power P is equal to I square R. Here we use I square is equal to P upon R. Then putting the values and taking square root on both sides. I square is equal to 150 divided by 95 and taking square root on both sides. So I is equal to 1.2568 ampere. Similarly, we can calculate the value of V according to the Ohm's law. V is equal to IR. So V is equal to value of I 1.2565 multiplied by 95. So the voltage V is equal to 119.37 volt. Now the result of question number 8. So the bulb is designed for a 120 watt. Now more videos, subscribe our channel. Best of luck. Allah.